Hey guys, I just wanted to do a quick little video for you that is dealing with a question that's going to be on the placement practice test that you're going to be doing starting tomorrow through Friday, whenever you have the time to do it. And this is going to be, actually I'm not going to start with how, we're just going to call it multiplying radicals. Because we talked about simplifying radicals, but now I want to talk about how to do some math with them. So we're going to talk about this in detail. So this is not a set of notes that you guys need to send to me. In fact, I'm just going to put it on the calendar, not in the grade book. This is just informational only, so I would suggest you watch this prior to starting your placement practice, okay? So multiplying radicals basically follows this way. We've got two examples for you, and we'll work through the examples. So we've got radical 2 times radical 6. So what's the same between those two values is they're both under a radical sign. So that's what we can do, is make it one big problem with just one big radical. And we'll talk about the property that allows us to do that. So we're going to go ahead, and this is a simplistic way of doing this, by the way, just to get us through that one question that's on the placement practice test. So I'm going to go ahead and take 2 times 6, and I get 12. But then we're going to go back to the stuff we had talked about, which was how to simplify. So we're going to look for perfect square factors that go into 12. So I know 4 is a perfect square, and it goes in 3 times. And then what we're going to do is take the square root of each of those. Okay? I can take the square roots of perfect squares, but I can't take the square roots of not perfect squares. So we're going to end up with a 2-part answer. Square root of 4 is 2, and the square root of 3 stays as the square root of 3, and that would be the answer. Okay? I don't know if you guys came across this on Alex or not when you were working on topics. So we have 3 radical 5 times 10 radical 15. So we're going to do the same exact process, but this time I've got coefficients that are outside. Oh, sorry, airplane going on overhead. I don't know if you can hear that. It's pretty darn loud. So, okay, so I believe I was in the process of saying we're going to multiply the coefficients together, just like that, because they're both on the outside. And then we're going to multiply the radicals together. So again, one big radical sign, radicals, radicands. Get your language down, Rosner. And we're going to do 5 times 15, okay? So on the outside, I've got 30, and then I have radical, and 5 times 15 is 75. So 30 stays 30. We don't touch coefficients, right? We only touch what's underneath the radical sign, the radicand. So then I'm going to look for any perfect square factors that I can multiply to come up with 75, and I have 25, and its partner would be 3. So if you notice, I always put the perfect square first. Okay, and then I'm going to go ahead and take the square root of both sides. So here's where it gets a little interesting. So we got that 30 on the outside, but when I take the square root of 25, I get 5. He also is on the outside. So what am I going to do? It's just one big, huge multiplication problem. So he's going to get multiplied by the outside guy, and I can't do anything with that radical 3, so he's going to stay there. Ooh, I didn't realize these both had a radical 3 in them. Look at that. So I'm still not done because I can do one more thing. Remember, math is do as much math as you can do until there's nothing left to try. So now I have 30 times 5 is 15, 150, 15. Whoa. 150, and then radical 3. And so that's how I get that answer. So that's the kind of issue that you may see on a question on the geometry placement practice exam on Edulastic that can begin tomorrow at noon. Okay? We'll talk more about it in class meeting. See you guys. Bye-bye.